Okay, so now we're finishing the 4-4 practice, as well as giving you a couple of hints for the Form G, which you do. So we did number 1 yesterday, so let's continue with number 2. State why the two triangles are congruent, then list all the other corresponding parts and the ones that are congruent. So the way I look at this, we're talking about this triangle, which is obtuse, with this other one that's obtuse. And so the way I look at it is angle, side, angle. Right there. So ASA is one valid way to do it because you do have a side marked between two angles. The other way to do it is if you notice XY and YX would be reflexive, you could do this as side angle side also. So side angle side would work. So either of those are valid. Either ASA, which is this one, or side angle side, which is that one. Okay, the next part is we need to name our triangle, and we'll call it AXY. So triangle AXY congruent to triangle CYX. CYX. The reason why I have to order it like that is because on the left side, the X is the obtuse angle, but on the right side, the Y is the obtuse angle. So remember about your corresponding parts. Now it wants to know what other parts are congruent. So first we know from reflexive that XY is congruent to YX. From reflexive we know XY is congruent to YX. And then all these others are from CPCTC. Just like all these were really CPCTC as well. So let's see, we know this angle and this angle. Our third angle is this little part of angle Y. I'm going to mark it in red, this part. So that'd be considered AYX. AYX congruent to angle CXY. So now we have the first couple of angles we already knew, and then we did this angle. We already talked about the reflexive side, so now we need to talk about the AY side. So AY congruent to CX. That would be from CPCTC. I think that's everything. We've already done this side and those sides and every angle. Yeah. So that's going to be your answer for number 2. Any questions? Okay. Number 3 is a bit weird. The reason is because if you look at the proof statement, this does relate to this figure, which is good. But in the description, it's talking about CYX, which is more that one. And so because of that, I'm going to skip number 3. So this was the figure we're using for number 3, and so I don't know why they made a mistake like that. Okay, so now number 4, it says copy and mark the figure to show the given information, explain why you would prove it, or how you would prove it. So right now there's only one figure, but there's 3 of them that are trying to use that figure, so let's draw it. If you would follow this pattern, draw a line straight down, and that's AB. And then tilt one up like that, and that's BD. And then straight down to E, and then connect to A. So generally go like that. So it says given AC is congruent to DC. So the C point is in the middle. AC is congruent to DC, and angle B is equal to angle D. So we would know automatically about any reflexive side or vertical angle, period. So in this case, there is no reflexive side. It's just this angle equal to this angle from vertical angles equal. And so because of that, this would be angle, angle, side, AAS. So your first step is to do that, and then explain why you would, or how you would prove AB congruent to DE. If you already know the triangles are congruent, then you'd say CPCTC. Corresponding parts of congruent triangles are congruent. So that's what we want for number 4. Number 5, draw the figure again. So just do it like that. And then label your points. You can go ahead and mark your vertical angles if you want to. Every other piece of information is different. Okay, so this says AE bisects BD. It's a segment bisector. So if AE bisects the BD, then this is equal to this one. So BC equals CD, or DC. And then this other part says DB bisects AE. So this one would equal to this one. So this would end up being side angle for the vertical angle and side, SAS. Side angle side. Remember, this lesson could help you with the previous ones if you are struggling on that, or just make you better or improve. Then for the AB congruent to DE, that's going to be from CPCTC. So what you'll notice is you can use any postulate or theorem, and then it'd be the CPCTC. Okay, number 6, draw your figure. Label it. And this one, well, let's go ahead and do our vertical angles right there. Okay, in this one we have AB is parallel to DE. So you put the little arrow thing right there. And then it says AC equal to EC. So that's this one equal to this one. Now, remember, if you're given lines are parallel, this would indicate alternate interior angles equal. So these would be your parallel lines, BD would be your transversal, and this would be equal to this one. So B equal D. So it's like two lines cut by a transversal, alternate interior angles are equal, because they're between the two parallel lines and they're on opposite sides of the transversal. Okay, so now based on our drawing, we've got angle, angle, side. Angle, angle, side. So AAS, and then again, once again, we put CPCTC. Any questions about that? Okay. On number 7, we have GK as the perpendicular bisector of FH. So the perpendicular bisector part means this causes a right angle here with these equal. And it says GK is the perpendicular bisector, which is given. The next two parts say definition of perpendicular bisector, but number 3 says with the right angles equal. So what we want for number 2 is about FK congruent to HK. FK congruent to HK. The next one is the reflexive on number 4, so that would have to be the side GK. GK congruent to GK. Reflexive. And these little V's are supposed to be triangles, so on number 5, if you would update that to look like a triangle instead. And let's see, we've got an angle in the middle, which is a right angle, and here's a side and the reflexive side. So that would be side angle side. The last part is to bring your proof statement down, so that'd be FG congruent to HG. FG congruent to HG. Remember that your reflexive side is in both triangles. The reflexive one is the one that's in both triangles. The triangle on the left and the triangle on the right. Okay. Number 8. ABCE is a rectangle. D is the midpoint of CE, which means this one is equal to this one. And it wants you to prove AD is congruent to BD. Okay, so there's your first statement, which is given. Then they have two that are definitions of rectangles. So AED is this angle, which is equal to BCD. So what this is in a rectangle, you have right angles in the corners. You don't have to write that part, but that's what part of the definition is. The other part of the definition of the rectangle is that opposite sides are congruent. Again, these are optional. And then they kind of leave you out here on your own to figure out the rest. So the first thing we're going to do is, you know that in our proof it has the word midpoint, and we haven't used definition of midpoint yet, and so let's use it now. Definition of midpoint. And so it'd be ED congruent to CD. ED congruent to CD. So then we do have our triangles that are congruent. I'm going to use the same order as number 2. So triangle AED congruent to triangle BCD. And that's going to be from side angle side. SAS. And the next part, put your proof statement, which was the AD congruent to the BD, and then CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so that's the end of the Form K. Now let me give you a couple of hints on this one. I will say you do this one, the Form G. This is like what you did earlier, except on number 4, I'm going to let you skip this one. You can skip number 4. Okay, and then we will do 6 together, like we did some of these others. This one has to do with construction of a triangle and constructing a midpoint, but we're not going to use the protractor or compass to do it. We're just going to draw it. It says use a construction to prove that the two base angles are congruent. You're given an isosceles triangle with base AC. If AC is the base, then that means this would be equal to this, and this one would be equal to this one. These are base angles since it's isosceles. Your base angles would be equal, and if those two angles are equal, then the sides opposite, this is opposite angle A, and this one's opposite angle C. So what we would know is that AB is equal to CB. So all that is about learning about isosceles triangles. Any questions before we continue? We don't know about our third angle, and we don't know about our third side. Okay, so for the proof we have ABC is isosceles, which was given, and AB congruent to CD. Okay, so this was a typo. It's supposed to be CB, not CD. So just change this right there to a B. So definition of isosceles triangle. Now number 3 says construct the midpoint of AC and call it D. So what we're going to do is we're just going to find the middle by putting a dot where these are equidistant, and then draw a line straight down and call it D. So we're not going to construct with tools, we're just going to mark straight down, and then these are equal. Any questions about that? Okay. Then the next part says definition of midpoint, and so we're going to use basically AD congruent to CD. AD congruent to CD. Then you have the BD congruent to BD. It's in both triangles, so that'd be reflexive. And then the triangle's congruent from, Okay, here's where it's going to look a little weird. You do have an angle here and an angle here, so you could use side angle side if you want to, or because of the reflexive side, you could use side side side. So in this problem, you could actually use either one and still be right. Any questions about that? Okay, and then for the last part, you do your proof statement, which is angle A congruent to angle C, and put CPCTC. Let me think about this one more time. In our proof, we didn't mention anything about angles. No, we didn't. If we used this side angle side, then we would need angle A equal angle C from definition of isosceles. So looks like if you want to use side angle side, you'd need one extra step. So you may want to just put side side side. Now that I think about that a little bit more, we'd probably want SSS for our answer. Any questions? Okay, so this packet is due Thursday? Yeah, the packet is due Thursday. You finish it. There's a Math Excel due tonight. And also there's a reflection due tonight on the altitude, median, and CPCTC. Okay, so you have the rest of the period to work on your stuff.